Hello everybody, this is Mr. Huebner, and this video is about electronegativity. So we're in our packet, unit number 5, chemical bonding. Scrolling down. So in order to talk about bond types, it all has to do with electronegativity, which is an atom's ability to draw electrons towards itself. So we could write that down. Ability to electrons towards itself. Now when atoms react to form compounds, they want to satisfy what is called the octet rule, which we'll talk about in following videos. But ultimately, having 8 outer electrons, or valence electrons as they're called, is ultimately the lowest energy and the most stable. So they want to have 8, and so they're going to either steal electrons from another atom, forcing a electrostatic attraction, or they are going to share electrons, form a molecular compound, and it all has to do with the electronegativity of the individual atoms that are involved in the reaction. There are multiple bond types we are going to be talking about in this unit. The two big ones, you've probably heard in middle school, are ionic bonds and covalent bonds. And as I said, ionic is the stealing of electrons, covalent is the sharing based off of electronegativity differences. And right here is a little periodic table showing all of the Pauling scale numbers for each individual element. And these are the electronegativity values. Notice they range from very, very low to as high as 4. If you understand periodic trends, the trends for electronegativity increase as you go left to right and bottom to the top, meaning fluorine furthest to the right and top is the most electronegative. Alright, doing some examples with these. Find the difference in electronegativity between atoms in N2. So we're dealing with nitrogen. That is 2 nitrogen atoms. So we've got nitrogen and nitrogen. Each nitrogen has an electronegativity value of 3. So 3 minus 3 equals 0. So the difference in electronegativity between atoms of 2 nitrogens is 0. And that would be a covalent. We'll talk about in another video how to equate these electronegativity value differences to determine whether it's ionic or covalent. And there's different types of covalent bonds that we'll get into. Right now, electronegativity difference. Sodium and chlorine. Sodium is 0.9, chlorine is 3. I always take biggest minus smallest. So 3 minus 0.9 equals, I'm thinking 2.1 if I did my math right. 2.1, which would be in the ionic range. Anything above 1.6 is ionic. And if it's below 1.6, it's covalent. Alright, H2O. This one's a little goofy because we have 3 atoms. Well, we're going to be talking about how to draw a structure of an atom in 3 dimensions, or at least 2 dimensions, called Lewis dot structure, where we can see how many bonds, because we're looking at the bond. And really H2O has 2 bonds. I'll just quickly draw it if I can. Alright, so we've got oxygen. Oh, my penmanship when I use more than a finger is a little bit better than this. But here's the molecular structure of H2O, and you'd have a couple of lone pairs at the top. Technically it'd be bent. It's going to get really fun. We're going to be able to draw those. You guys already had a sneak peek earlier this semester. But notice how I have one HO bond and a second HO bond. So we're just talking about one of them. Like an H and an O, what's the electronegativity difference? All right, moving on to O is 3.5 and H is 2.1. So 3.5 minus 2.1 equals, oh, that's some tough mental math right there. 0.9, is it 1.4? 1.4, which is below 1.6, meaning it is a covalent bond. All right, moving on to the next question. Use your electronegativity value, or table, to find the values for each of the following atoms. So this is fairly simple. We're just looking at, all right, fluorine's 4. All right, there you go. So you type in 4. Aluminum is right here. It's 1.5. 1.5. Then we got hydrogen, I believe is 2.1 if I remember. Yes, 2.1. 2.1, and then we got oxygen is 3.5, copper is 1.9, and sodium, so copper is 1.9, sodium is Na 0.9. And that's simply that, is just using the electronegativity table. All right, number 2, circle the most electronegative element in each pair. We got calcium and manganese. So calcium is right here, and manganese is right here. So 1 versus 1.5 looks like manganese is the more electronegative entity. So I'm just going to highlight that. There it is. Then we got gallium versus sulfur. Gallium is 1.6, sulfur is 2.5. 2.5 is definitely the more electronegative entity. And then we got lead versus selenium. Selenium is 2.5, lead is 1.9. So selenium is higher, it is more electronegative. And then silicon versus fluorine. I know fluorine is the most electronegative, but just double check so you can see silicon's 1.8, fluorine's 4. So fluorine is definitely more electronegative. All right, one last one. Find the difference in electronegativity between atoms in CaF2. Again, this is like H2O. Yeah, so we have 2 different bonds. We got a calcium-fluorine bond and then another calcium-fluorine bond. So you just got to talk about one of them because they're the same. So calcium and fluorine, we want to find the electronegativity difference. Fluorine's 4, calcium's 1. So it's 4 minus 1. You got it, 3. 4 minus 1 equals 3, which would make that a very ionic bond because it is greater than 1.6. Good job. All right, that is it for this video. Hope you enjoyed it. Have a great whatever time of day it is for you.